You're standing in an open field, looking up. Above you hangs a giant. It's a white, fluffy cumulus cloud, drifting lazily across a blue sky. It looks weightless, like a rogue piece of cotton candy or a handful of steam. But looks, as they often do in physics, lie. That single cloud, the one you're looking at right now, likely weighs about 500 tons. That is roughly the mass of 2 blue whales, or 100 elephants, or a Boeing 747 fully loaded with passengers and fuel. And yet, it doesn't fall. There's no engine keeping it aloft, no wings generating lift, and certainly no invisible tether to the heavens. If you were to suspend 500 tons of lead, or even 500 tons of loose wool in the middle of the sky and let go, it would hurtle toward the Earth with lethal inevitability. So why does the cloud stay up? Why doesn't the sky collapse under its own weight? To answer this, we have to stop thinking of the air as nothing. We live at the bottom of a vast, invisible ocean. We are deep-sea creatures walking on the floor of an atmospheric sea, and just like the water in the Pacific, the air around us has its own rules of buoyancy, density, and hidden violence. The mystery of the floating cloud begins with a paradox of scale. A cloud is not a single object. It is a massive, shifting collective of trillions of tiny water droplets, or ice crystals. Each individual droplet is microscopic, about 10 times smaller than a human hair. Because they are so small, they have a massive amount of surface area relative to their weight. Imagine dropping a grain of sand into a swimming pool. It sinks, but slowly, because the water resists its movement. Now imagine that grain of sand is even smaller, so small it's barely a speck. The air itself, which feels thin to us, feels like thick molasses to a cloud droplet. This is the realm of terminal velocity. For a droplet this small, the drag or air resistance it encounters as it tries to fall is almost equal to the pull of gravity. It is falling, technically, but at a speed so agonizingly slow, maybe a few centimeters per hour, that any slight breeze can cancel it out. But air resistance isn't enough to keep 100 elephants hovering over your house. There is a more powerful, invisible force at play: convection. The sun beats down on the Earth's surface, heating the ground. The ground, in turn, warms the air directly above it. As this warm air expands, its molecules begin to dance more vigorously, pushing each other apart. The air expands, becomes less dense than the cooler air around it, and begins to rise. This is an updraft. Think of a cloud not as a static thing, but as a fountain. When you look at a fountain, the water seems to hang in a specific shape in the air, but the individual droplets are constantly moving, being replaced by new ones from below. A cloud is a visible ghost of an invisible rising current. As the warm, moist air rises, it eventually reaches a height where the pressure is lower and the temperature is colder. The water vapor, the invisible gas, is forced to condense into liquid. It hitches a ride on microscopic bits of dust or salt in the air, creating the droplets we see. As long as that warm air continues to push upward, it acts like a giant, invisible hand, holding the 500-ton giant in place. The cloud is literally surfing on a pillar of rising heat. However, this brings us to a deeper, more beautiful realization about the nature of matter. We often categorize things as solid, liquid, or gas, as if they're fixed states. But the cloud teaches us that liquid can behave like gas if it is broken down into enough pieces. The cloud is a transition state, a borderland between the earth and the void. But what happens when the balance shifts? What happens when the invisible hand of the updraft gets tired, or when the droplets get too greedy? Inside the cloud, it is a chaotic, crowded ballroom. Trillions of droplets are bumping into each other. Sometimes they merge. This process, called coalescence, is the beginning of the end for the cloud's levitation. 2 droplets become one larger drop, then 4, then 8.
As the drop grows, its weight increases much faster than its surface area. The molasses of the air can no longer hold it back. Gravity, which has been waiting patiently for this moment, finally wins its tug of war. The droplet begins to fall, and as it falls, it sweeps up more droplets, growing even larger, gaining momentum until it streaks out of the bottom of the cloud. We call this rain. Rain is simply the moment the sky becomes too heavy for itself. It is the redistribution of weight. When you stand in a rainstorm, you are feeling the impact of a cloud that has finally lost its battle with the laws of physics. But there is a philosophical weight to this as well. We often use clouds as metaphors for the ephemeral, the dreamlike, and the light. We treat them as if they are the opposite of the heavy, real world. Yet the reality is that the atmosphere is a theater of immense power and crushing mass. If you were to take all the water suspended in the atmosphere at any given moment, it would weigh trillions of tons. There is more water floating over our heads than there is in all the rivers on Earth combined. We are living beneath a suspended ocean, held up by nothing more than the vibration of atoms and the heat of a distant star. This leads us to wonder about the weight of things we cannot see. We perceive the world through a filter of our own scale. To us, a 500-ton cloud is a fluffy decoration. To a microscopic organism, that same cloud is a vast, dense forest of liquid spheres. To the Earth, it is a mere cooling blanket.
Our human intuition is often a poor guide for the scales of the universe. We see the world through the lens of our own strength and our own size. We think of heavy as something we can feel in our muscles, and light as something that escapes our grip. But the cloud reminds us that weight is relative to the energy supporting it. Consider the air itself. We don't feel the weight of the atmosphere, yet there is roughly 15 pounds of pressure pressing down on every square inch of your body right now. You are carrying several tons of air on your shoulders, but you don't collapse because your internal pressure matches it perfectly. We are adapted to the heavy, and so we perceive it as nothing. The cloud is simply the visual manifestation of that nothing becoming something. This brings us to a haunting realization about the Earth's delicate thermal balance. If the sun were to dim even slightly, the updrafts would fail. The invisible pillars of heat that hold the clouds aloft would crumble. The suspended ocean would fall, not as a gentle rain, but as a catastrophic planet-wide collapse of water. Conversely, as our planet warms, the atmosphere gains the capacity to hold even more water vapor. The hidden oceans above us are growing heavier, more energetic, and more volatile. We are thickening the ceiling of our world. But beyond the physics of thermodynamics and terminal velocity, there is a certain poetry in the cloud's existence. A cloud is a temporary alliance. It is a collection of trillions of individuals, water droplets, working together to defy gravity, if only for an afternoon. It is an entity that has no hard edges. You could fly a plane through a cloud and never hit it. Yet it can block the light of a star 93 million miles away. It is a reminder that the universe is not just made of stuff, but of processes. A cloud isn't a thing that exists in the sky. It is something the sky does. It is a verb, not a noun. It is the breath of the earth, condensing in the cold of the heights. When you look up again, don't just see a fluffy white shape. See the 500 tons of water. See the invisible geysers of hot air pushing against the relentless pull of the Earth's core. See the microscopic battlefield where drag and gravity are locked in a stalemate. We live in a world where the heavy can be made light, where the invisible can become visible, and where 100 elephants can dance over our heads without ever making a sound. It is a fragile, beautiful illusion, sustained by nothing more than the warmth of a sunlit day and the stubborn resistance of the air we breathe. The next time you see a shadow pass over the ground, look up and acknowledge the giant.
It isn't floating because it's weightless. It's floating because the world is far more powerful and far more supportive than we usually give it credit for.